Hello, my name is Rich Howard, owner of Architectural Builders Supply. This video is to bring you a closer look at the Bommer number 7811-646. This is a double-acting spring pivot with the floor plate, medium duty, and we'll talk more about that in a moment. Hold open style in a 646 finish. Now that specifically means satin nickel. That means satin nickel on a steel base. Okay, so satin nickel finish. So let's start at the beginning of analyzing this item. First of all, the Bommer 7811 is one of their series of double-acting floor pivots. It happens to be the medium duty rating, which is specifically rated for 90-pound doors up to 3 foot wide, 1 3/8 to 1 3/4. It is also hold open, meaning that when you get the door out to about 90 degrees, 95 degrees or so, it's going to hold open until you tug it back closed. They have light duty units that are in the 60, 70 pound range, and then they have heavy duty units which are up in the 130 pound range. Hold open and non-hold open are generally available in both of those as well, along with a full complement of other finishes. Satin nickel is certainly very common, especially these days. Okay. Now, moving forward, this is a double-acting pivot, something you're going to see very commonly in residential applications between the dining room and the kitchen. You'll see a pivot like this. Very common. Other applications, I've installed these in restaurant applications, that same sort of door. You'll have these in tenant build-out for private offices. Whatever reason, they want double-acting doors, especially pairs of doors. Okay, very common as well. The hold-open feature is accomplished by, and while you can't really do it with your hand because the spring is too strong, but as you turn this, you can see this lobe that's here. And as you turn that lobe, there's a bird's mouth that's cut on the inside of the item here, and that lobe will fit into the bird's mouth and stay there until you push it or tug it either way, and then the spring will take control over it again. This is an adjustable spring tension, and that is accomplished by the included tension rod into the holes in the tension collar and turning it either clockwise or counterclockwise. And that will allow you to set the tension on the spring. You get the concept on how that works. Okay. Very important that you're within the door weight range. You don't want to exceed that. The spring will fail. It's not made for anything heavier. You'd go with a different unit altogether. The 7813 is probably a unit you'd look at. This model specifically has the floor plate versus the jam plate that you can also get, meaning that it will attach directly down to the floor with these screws, with these holes for the screws. Now, the meat and potatoes of this video is analyzing the installation. There is a link below this video to both the template and the instructions. And both of them are important documents to review. They primarily give all of the same information, except that the template gives a technical drawing on every component basically in the set. And while we won't cover all of the measurements of this material because you can refer to it there, it is simply available there for you to review. So let's focus on the installation instructions, and we'll go through all that. And at this point of the video, that's where I'm going to go through the installation instructions. Step one, when you look at the installation instructions, you see specifically that you have to accommodate an 1.5 inch radius on the edge of the door. And that makes for a very large sort of roundover bit that you have to have. An 1.5 inch radius is 3 inch diameter. However, a double-acting door, if the edge of your door is square-edged like my fist is, you can get the idea that unless those edges are radiused over, your door would not work properly in the jamb because the door would end up hitting the jamb. Everything that is drawn out on the templating here is based on the lock edge or the side with the push plates being radiused. If you cannot accommodate that radius, and it's understandable that you couldn't because it's a large tool that you need to have in order to do that, you need to increase the margin there. And in my opinion, you're going to need to increase the margin substantially in order to accommodate that. It's drawn out, if we look forward to step 2 a little bit, at 1/4 inch. However, that's not the lock side. That is the pivot side. You can, when you accommodate that sort of 1.5 inch radius, you could make that margin a little bit less, especially the lock side. You can get that down to about 1/8 of an inch. But everything that you're going to be dealing with in terms of the templating for this is based on a 1/4 inch margin between the hinge or the double acting pivot side of the door and the edge of the door. So now back to step 1. When I have done radiuses on doors like this, I would, because in a shop setting you'd encounter them often, I would have a standalone router, like a 1.5 horse single router that was fitted with a round over bit of the proper radius, diameter. And because that's such a large router bit that you have to fit inside of the tool, I would take the router base and I would cut it out, the inside hole, so that I could fit the tool up and into it. I would never change that setting on there. The depth I would leave. I would have the tool just set for doing that. And if you're dealing with 1 3/4 doors, you would never have to change the depth of the router bit whatsoever. If you're doing that thickness all the time. 1 3/8, you just have to reset the depth. And what I would do when I have done it in the past, I would take my door, I'd put it on saw horses, and I would clamp it down. I would start at the one long end from the right side, and I'd get my router firmly on the door. And you have to be careful because it's probably a higher power router, like a 1.5 horse, and a large bit, so a lot of centrifugal force happening. So as soon as you power that on, you'll know that you've got something turning. So get it stable on the door, and you'd make one pass, keeping the base flat on the face of the door, and then just one more additional pass just to clean it off and any sort of tipping that you may have done as you've made that first pass, with it being very critical that when you get to the end of the door that you don't try to push forward, you just want to exit the end of the door. Okay? Do the one side, flip the door over, repeat that process, then turn the door over this way, repeat the process, flip it over, and do it one more time, and then you've got a radius on the edge of the door. Keep in mind that the door construction needs to be compatible with doing that sort of machining to it. If you're dealing with a veneered door, keep in mind that you're going to be exposing the different layers of the veneer. If you had maple, for instance, you would see the very clear white, light-colored wood, and then you'd have a much darker cross-banding underneath it, so you'd be exposing that. That might be an issue for a client. I know that it has been in the past something that needs to be discussed up front before you do that sort of treatment onto a veneered door. Anyway, you might have to do some other door construction or some type of veneer wrapping after the case. Now, moving on to step 2, what you're going to be seeing here is a preparation in the top of the door for the top of the door and the header, actually, for the top pivot. And this pivot is included with it. I believe the part number is 7890. And the male portion is what goes up into the header. The female portion goes to the top of the door, and you'll drill a hole in the top of the door to accept the top spindle. Preparation for this, you can see there in step 2, where you go 1.5 inches over from the edge of the door, and that'll be the center line of this hole. And then you're 5/8 this way and 5/8 this way. Okay. Mortise 1 inch diameter hole, top of the door, 5/32 deep. So when I've done this in the past, I've marked my 3 holes. I would take a 1 inch Forstner bit and go in. 5/32 is just over 1/8 of an inch, so you don't need to go very far. But that Forstner bit will give you a very clean finish on the holes that you don't have to go back and clean up. You just have to drill it pretty accurately for that to be there. Then, the same sort of process in the header is what you would accomplish. Drilling that 5/8 of a diameter hole, 5/8 deep from the top of the door. Critically installing this at 1.5 inches, saying it again, from the edge of the door to the center of that hole, because that 1.5 off the edge of the door is going to be your vertical axis of pivoting that needs to be compatible with the bottom pivot assembly. Reading step 2, prepare 1-inch diameter cutout and top of door and header. Install the top pivot into the header and mount the top pivot plate into the top of the door. Both the top pivot assembly and the spring pivot in the bottom of the door must be plumb on the same center line. Screws are going to be included in your screw package for getting all of that attached. Moving on to step 3. Step 3 is a lot easier than it looks, quite frankly. When you look at all of the dimensions, basically what it's saying to you is make this fit onto the bottom of the door. It's just that simple. This plate needs to be flush with the edge of the door. This ear or tab over here needs to be flush with the bottom of the door. This needs to be in the center of the door. Now, when I've done this in the past, I would have a template with this preparation on it, so I can take my plunge router now and make that sort of trace and do that all the way through the door, and then I would just have to go up and clean out the 3 inside corners to make sure I was getting everything prepped. If you're not going to be doing that with a router, it's a lot of work to chisel is the bottom line, and a circular saw certainly isn't the right way. I've had people do it with jigsaws as well. You use the tool that you're familiar with and or most comfortable with. There's one additional process that you have to do, is that 1.5 long, 1/8 inch deep groove, and that's for the pin that's in here because it travels as the door is open and closed. Okay. Step 4 shows basically installing the spring pivot onto the bottom of the door, and you're going to get screws for that as well in your screw package. You'll see the 1 3/4 center line. That, of course, is 1.5 from the edge of the door because you've got your 1/4 inch margin. One crucial dimension is actually missing from this installation instructions. And it, quite frankly, should really be there. We know that we're going to be roughly is the net size of the door. So if you've got a 1/4 inch margin for the pivot jamb and the edge of the door, assume a 1/4 inch margin on the other side. So you're 1/2 inch smaller than your finished opening, but the question becomes, what's the height? And that dimension is what's given on the template, and that shows 9/16 at the bottom of the door to the floor. Allow 1/8 of an inch at the header, so now you're at 11/16. So if you've got an 84 inch opening, or let's say an 80 inch opening, you're going to be at 79 5/16 overall height. That information should be first and foremost on your installation instructions. And quite frankly, after the 9/16 reference on the template, there's nothing else on the template that you can't get off of the installation instructions. Now, moving back to installation instructions, step 5. Insert the top pivot into the top plate. So you're basically going to make these two come together by taking the door and getting it into the opening, and then tipping it in. You want to make sure that you're plumb, square to the opening. You're going to mark your holes down here. You're going to remove the door. You're going to drill your holes. You're going to bring it back in. You're going to securely fasten the floor plate down. And then at that point, you're pretty much done. The last thing that you actually have to do is simply get your heel plate on, and then these cover plates that we talked about earlier that are going to cover everything up. And there's, of course, 2 of them. Okay. There's a machine screw for holding the heel plate on into the threaded holes here. These 2 are going to take screws for you to hold it to the door securely. Okay. And that is step 6, securing it to the bottom of the door. Install side plates as shown. Attach back plate, which I've called heel plate, using the self-tapping machine screw. They'll say that you'll use the top holes only in the side plates because there will be no wood left down here because you've machined for those, which I've always wondered why Bommer doesn't redesign their plates. At that point, you should be in real good shape, short of just adjusting for operation with your tension rod into the tension collar, as indicated earlier. Now, Bommer is a full-line manufacturer of all things double-acting hinge and pivot related. Not all things, but a comprehensive offering. They have a double-acting hinge or pivot for basically every scenario that I can think of when you're dealing with lighter duty doors in comparison to the full range of commercial doors. They don't have a double acting floor closer for a 500-pound door. That is not their business. But residential stuff, a lot of commercial applications, their material is very commonly seen. You can't really see that logo down there at all, but right above it says Made in USA, a fact that Bommer is quite proud of, as am I to represent them. This is made in several different finishes, if I've not already said that. 646 satin nickel is not the most common, but certainly very popular. Black, your brasses, oil rub bronze, chrome, both satin and polished. Prime coat, of course, zinc plated is good if it's in a restaurant situation. It's significantly less expensive than satin chrome or satin nickel and gives you a similar look. If you have any questions on the Bommer 7811-646 double acting spring pivot or any other Bommer product, please feel free to reach out to us. Thank you.